So I wanted to do another video on section 17.3. If it totally made sense to you guys in the first video, awesome. But if you're saying, I'm not sure I understand how to determine if figures are similar or how to figure out the scale factor, then this is the video for you. If you understood everything in that first video where we talked about determining similarity, scale factors, and solving proportions, then you're golden and you don't need this video and you can literally turn it off. But if you want more help, here it is. So I'm going to take a look. This is actually going to be coming from your assignment. So I'm going to do some odd problems and you guys are going to be tasked with some of the evens. So let's take a look at, and I'm going to sketch my pictures so you guys know they aren't going to be perfect, but we're going to kind of roll with it. Let's do this guy. So here's the question. Are the figures similar? If so, find the scale factor. So I'm going to draw this guy right here. This is a trapezoid. And that's its measurements. And then I'm going to draw this guy who is purposefully going to be flipped over and obviously bigger. So the first thing we want to look at when we determine if figures are similar, we want to look and see, do the angles match up? So on the longest side, I have two single loop angles, meaning they're the same measure. On this figure, on the longest side, I've got those two angles being the same measure, and they match up to each other. On the shorter piece, I've got double loops. Hey, that matches. So it appears that all of the angles are congruent, meaning they're matching to the appropriate same locations of the same size angle. So the next question is, do we have proportional sides? And so we need to start taking a look at do these sides correspond properly to each other? So I'm going to start on my second figure, and I'm going to choose the biggest side. I'm going to compare that 21 to the biggest side here, and notice that the 21 is kind of trapped by single looped angles. Well, the 14 is the biggest side on this figure, and it's trapped by the single loop angles. Well, let's figure out what 21 over 14 is. It's 1.5. So that means that if these two figures are going to be similar, then when we create these fractions, these ratios, they have to be what we call proportional. They all have to equal 1.5. So let's try the other piece right here. Let's take the 10 over the 8. And we know that the 10 and the 8 correspond because they've got the double loops and they're the shorter of the sides. Well, that's 1.25. These are not proportional because they are not giving you equal values from the two fractions. So we would say that these are not similar figures. So I can't find the scale factor. Well, let's take a look now at ones that will be similar. Let's do this nice, lovely rectangle. And I'm going to tell you, even if it's not perfectly drawn well, that this is going to be a set of 90-degree angles all the way around. And we're going to compare it to this itty-bitty baby rectangle. So all of the angles are corresponding. They're all 90 degrees, and they're going to match up. Well, I'm going to tell you that this is 16, and that's 16, and that this is 12, and that's 12. Let's see. Here we go. I'm going to tell you this side is 11.2 and that side is 11.2. And the top and the bottom are 8.4. So the question is, are they similar? Well, I'm pretty sure the left and the left are going to match. So I'm going to take 11.2 divided by 16. That gives me a 0.7. And if I take the other 11.2 and the other 16, it's also going to give us a 0.7. So the left and the right, we're good to go. Well, let's take the 8.4 divided by the 12, because the tops are going to match. And then technically the 8.4 divided by the 12 for the bottoms. But once I do one, I've got the other. So 8.4 divided by 12 is 0.7. Awesome. When we create these corresponding sides and they simplify to be the same value all the way around the figure, if these are all equal, all of them are equal, then yes, we have a similar set of figures. So the next question, what is the scale factor? Well, the scale factor is that value that we get. So we're typically going to take the second figure divided by the first, because we're pretending that this second one is the image and the first one is the pre-image. So our scale factor is this value of 0.7. Kind of nifty. So that's how we determine if we have similar figures. We're comparing those sides, and they all have to come down to be the exact same value. So I'm hoping that that helps you guys. Now, I'm going to do just a little bit more. This is just kind of a second video, just more reteaching, because I'm afraid I went too fast in the first video. So again, if I tell you guys that these two are similar triangles, and I say that this is 16 and 5, and I'm trying to find something that's going to work here. This guy is 6.4, and this one is x. Okay. If it's drawn like this, we're probably pretty comfortable that those two are going to be our corresponding sides. But if you're not ever sure, then you can always ask me to say, hey, help me with the angles. So the x is trapped between the single loop and the triple loop. The 5 is trapped between the single loop and the triple loop. So these guys are going to correspond with each other. The 16 and the 6.4 are going to correspond. So because they're similar, when we create these fractions, we're going to get an equal piece. So let's take the x and put it over the 6.4. We're taking a look right here at the same shape. Well, across from the x, because across that in the other figure is the 5, across from the 6.4 is the 16. There are other ways to set up these equations. They could be flipped, they could be changed. There are some wrong ways. So if you are saying, I learned it a different way and this is messing with my brain and I want to do something different, you need to send me a picture or a video of saying, hey, will my method work? Because if your method works, you can use it. If it doesn't work, I'll explain why and we'll come up with a way that works. This way will always work. So if we go diagonal, we'll have 16x equals 5 times 6.4. I just always put my x on the left-hand side. It's how I was trained. Well, 5 times 6.4, hey, that's 32. So if I divide away the 16, we'll get x equals 2. So just another little video, just some more examples. I just want to make sure this makes sense. If you have any questions or need any help, please let me know.